Welcome back, grade 12. This is a continuation of our differential calculus videos, part 2, rates of change and equations of tangents to curves. These are two types of applications of differential calculus. Part 2, rates of change and equations of tangents to curves. In this lesson, we're going to look at the concept of rate of change and some real-life problems. Then we're going to look at the concept of equations of tangents and some real-life problems. And then, as usual, there will be an exercise worksheet for you to practice these two applications. Okay, before we actually start, let's just have a quick revision of the differentiation rules, application of the differentiation rules that we did in the first lesson. There are 5 problems here, 1, 2, 3, 4, 5, and I'll be very generous, I give you 30 seconds for each. Come quickly, just write down the answers, don't need to write down the actual question. Okay, ready. First one, let's check your answer. That's right, 6x squared plus 18x plus 14. What happened to the negative 24? That's right, the derivative is 0. Can still remember why is it 0? That's right, the gradient of a constant is going to be 0. The next one, negative 9x squared plus 10x subtract 16. Be careful there with the negative. That one, 12x squared minus 22x minus 2. This one, be careful here. Negative 3x squared plus 2bx minus 2a. The last one, 3ax squared plus 2bx plus c. Okay, so now it's ready. This is what you're going to need. Just be able to use your differentiation. Now, the first one we're going to look at is rates of change and some real-life applications there. There are two types of rate of change that we're going to look at. First one is average rate of change, and the other one instantaneous rate of change. Let's start with the average rate of change. Average rate of change of function defined by fx between x equal to a and x equal to b. So that here with the average rate of change we use our gradient formula. In this case, if we use it in function notation, it's fa minus fb over a minus b. You can also do it the other way around. fb minus fa, then it has to be b minus a. So it's just your gradient that you're calculating here. Instantaneous, the rate of change of the output variable fx with respect to the input variable x at the point. You see there's a point. There we had points at the point where x is equal to a. And that's what we refer at the instant where x is equal to a. In this one here, excuse me, we're going to determine the first derivative. And after determine the first derivative, we're going to substitute the value x equal to a into that first derivative expression there. And that will be your instantaneous rate of change. Very simple. Average is just one procedure to have to follow. Substitution into your gradient formula. Instantaneous rate, you need to first differentiate and then substitute. Remember, first differentiate and then substitute, not the other way around. We're going to look at two rate of change application examples. During an experiment, the concentration of glucose in the human body MT varied according to the formula MT equal to 4,8 minus 0,3 t squared, where t represents time. First question, find the average rate of change of the concentration between t equal to 1 and t equal to 2. Notice when they have average, they have to provide you with two values here. Average rate, we use the gradient formula. In this case, we have it in function notation, m1 minus m2 over 1 minus 2. Or you can say m2 minus m1, then I have to say 2 subtract 1. Please be careful of the order there. So let's do that. First of all, let's do the easy part. What is the easy part? That's right, just 1 subtract 2. Always start with the easy things first. m1, substitute m1 in there, then you substitute m2, so you have to put the 2 into that, you get that. This is now just simple calculator work, and you're supposed to get this correct without any errors there. So that gives us negative 0,9, or you might even have negative 9/10. Let's look at the second question. Determine the rate of change. You see, rate of change of the when t, there's only one value there. This is actually asking us for the instantaneous rate. What are the steps we said there? Right, in the correct order. First differentiate and then substitute. So what do we have to differentiate? Differentiate m prime t. That gives us negative 0,6t. And then we have to substitute. What do we have to substitute? They said t equal to 3. So if we substitute 3 into the derivative there, we end up with negative 1,8. Now they ask us here, interpret the answer obtained in B. So there's the answer in B. This is a rate. So how can we interpret this? Look at the value of that rate. What type of value is that? I know it's decimal, but it's actually a, that's right, a negative number. And when you have a rate that is negative, what does it indicate to me? That the rate is actually a decreasing rate. In this case, it's just in context, the concentration rate of glucose is decreasing. Let's take a second example. A particle, an object, moves along a straight line. The distance s in meters of the particle from a fixed point on the line at time t seconds is given by, so t is in, the time is in seconds. Let's see the question here. Give the particle's initial distance from the fixed point. Initial distance? What do we mean by initial? That's right, the start, or else the beginning. So you start at, the time would be, what would the time be? That's whenever you have initial, time is 0. So I substitute t equal to 0. So that will be s0. We substitute that, we end up with 45. And s is the distance, so the unit should be 45 meters. But the next question, calculate the particle's initial velocity. Now here they just help you. Those who do physical science would know what velocity is. Velocity is the rate of change of distance over time, or distance with respect to time. So we have initial velocity. What does initial mean? It's when time is 0. So how do we determine the rate of change? That's correct. Let's differentiate. So we take the distance, we differentiate that, which gives us 4t minus 18. And after differentiating, I need to substitute, but which value? There's no value given, but the clue here is initial. And initial means when time is 0. So I work out, substitute t equal to 0. Then I end up with 4 times 0 subtract 18, which gives us negative 18 meters per second. Right? If they asked us to interpret this, what would we say here? That the velocity is decreasing. Now we're going to look at the second application here, equation of tangents to curves. Remember, as we said, we used to do in analytical geometry equation of tangents to circles. Now we're going to look at tangents to any type of curve there. So let's look at the general procedure. Let's say there we want to determine the equation of the tangent to the curve defined by, and there they give you the equation there, at a point x equal to k. Remember, a tangent to touch a curve at one point. So let's look at the general procedure. They give us x, so we can determine the corresponding y value. How do we do that? That's correct. Substitute x equal to a in your expression, then you work out, calculate fa. The next thing, we find the first derivative. So you have to take your equation and you differentiate. Right? So we'll do differentiation. The next thing, we have to determine the gradient. Now remember, this first derivative is actually the gradient of a tangent. So the gradient m will be the first derivative, but now but it needs to be first derivative when I have x equal to a, so I must substitute a into the first derivative. Then we're going to find the equation. What is a tangent? That's correct, it's a straight line, and it's advisable for you to rather make use of this formula for determining the straight line. You have a gradient and a point. You see there you've got an x and a y, so there's a point. And you have this, so this will be much easier to have this instead of using the other formula. You know the other one? Y equal to mx plus c is the one that you're going to end up with. We're going to look at two examples. The one example I refer to as a direct application. Direct in the sense that the question is clear what needs to be done. Determine the equation of a tangent. In this case, we want to determine the equation of the tangent to the curve defined by, there you have the defining equation, at a specific point, and at the point x equal to -2. So what do we need to do first? That's correct. We need to determine the corresponding y value. And to do that, we substitute -2. So we determine f -2, and that gives us 8. And the next step would be, that's correct, determine the first derivative. So what's the first derivative? Try that. That's correct, -6x squared plus 4. Because we want the equation of a tangent is a straight line, so we need the gradient of the tangent. And how do we determine that? By substituting, because f prime x, and if I substitute the -2, is actually the gradient. So m is equal to f prime -2. Substituting, we obtain a -20. Now we're ready. The equation of a tangent is a straight line, so we use the straight line formula. I recommend you use this version here, where you have the gradient and a point. Gradient we've just calculated, the point x1, the x1 was given, the y1 we calculated. So this is a substitution, and we can simplify this by expanding and transposing. That gives us that expression, and then finally simplifying, we now have the equation of a tangent, and this here is in standard form, y equal to mx plus c. Let's look at one more example on equation of tangents. This particular one, I refer to it as an indirect. Let's see why indirect. The equation of the tangent to the curve of G, defined by that, is given by. Which one is the equation of the tangent? This or that? That's correct. It is the linear one. Why? Because the tangent is a straight line. This is not the tangent's equation. Determine the point of contact. What do we mean by that? That's correct. Find the x and the y. What does this mean? X greater than 0 means the x coordinate is positive. So let's see. We don't have the x. We don't have the y. We can use the equation to find m, and we still need to differentiate. See, these are the 5 components of such a question: a x and a y and a m and a derivative and an equation. So equation we have. We can use the equation to find the gradient. We've got the curve, so we can differentiate, and then we can find the x and the y. So let's see. The gradient of the tangent, I take my equation, write it in standard form, and what's the gradient there? Correct, m is equal to 5. Then we need to differentiate. Let's find the derivative. Try the derivative. That's correct, 3x squared plus 2. Now we need to know that the derivative, there is the derivative, but the derivative there is the same as the gradient, which means 3x squared plus 2 is equal to 5. This is equal to the gradient. That is a quadratic. Transpose the 2, becomes a 3. Divide by 3, so I end up with x squared equal to 1. So if x squared is equal to 1, what should x usually be? That's correct. X is equal to plus or minus 1. However, they told us here x is greater than 0, so we do not want the negative value. Okay, if this was not given, we had to give both answers there. Now, did we answer the question? That's only the x value. We also have to, they said point of contact, which means the x as well as the y. See, they gave us this, we did this, we could find that. We now have the x, so then we have to see, you ought to get all 5 of them there. So the corresponding y, so I must substitute 1. In which one can I substitute 1? Either into the g, or I can substitute it into this here. There's also a y. Which one will be the easier? It's always better to do the easier one. There's less chance of making a mistake there. But irrespective, whether you put 1 into that one or into that, you'll get exactly the same answer. In this case, it's 6. Now let's answer the question. Point of contact is the x and the y, which is 1 and 6 there. Those are the types of examples you can get. On rates of change, there are 2 types, average and instantaneous. Average, you use the formula. Instantaneous, you differentiate, substitute. Equation of a tangent, the 5 steps, what are they again? X value, y value, differentiate, m value equation. Right, those 5 components. Just have those 5 on your fingertips there. So, but before you actually do this exercise, as before, remember, I always recommend you try the worked out examples on your own without looking at the solution. Then compare your solution with the provided solution on the slide. And then once you've done that, you need to do that. Let's look at an example here. There we have an example, and there we say determine the rate. Right? Just the rate, not average rate. Determine the rate of change. Here we say initial. You know what initial means? Determine the temperature when T is 3. Determine the rate when it's changing. And there they want us to interpret. Then we have some questions on tangents. This is a direct. They give us the curve and they give us the point. Here they give us the equation, but they want to know what is that k value there. Remember the 5 components? A line with a gradient of negative 11. What do they tell you here? M is negative 11. Here they want the x coordinate of the possible. See, there are 2 possible answers here. Here we have a few more questions on tangents to curves. That you can see is that's right, it's a direct one. This is not direct because they give you the tangent, right? You have to find some values here. But remember the 5 things: x, y, derivative, gradient, equation. Right? You just tick off what you have, you can see what's missing. There we have a equation, so we've got the gradient, but we can differentiate and use it with that gradient. They give us the x value, it's easy to find the y value here. Question number 7, determine the value of k if y equal to 4x plus k is a tangent to the curve. We are given the equation, so we have the gradient. We can differentiate and you can find the value of k. That's all at this stage. So class, you if you subscribe to my okay, sorry.